Hi, my name is Jill Torrey, and today we're going to be covering these two problems from Chapter 5 in our textbook. The first one is from Section 5.4, and it covers this learning objective right here. The problem reads, calculate its volume in liters of 88.4 grams of carbon dioxide at standard temperature and pressure. It is known that standard temperature and pressure is 1 atmosphere and 273.15 Kelvin. It is also known that 1 mole of any gas at standard temperature and pressure occupies 22.4 liters. The first step was to find what 1 mole of carbon dioxide is, and I did that by adding the atomic masses of each element in this compound, and I got 44.0 grams as the molar mass. I then used that conversion, and the conversion of 22.4 liters is equal to 1 mole, and set it equal to this, and I multiplied all of them out to get 45.1 liters of carbon dioxide, and that would be the amount of liters that carbon dioxide is at standard temperature and pressure. The next problem covers section 5.1 in this learning objective right here. And the problem is, name 5 elements and 5 compounds that exist as gases at room temperature. And so one of the first things that we can look at is knowing that ionic compounds do not exist as gases at room temperature, because the cations and anions are held together by very strong electrostatic forces, and it takes a large amount of energy to overcome the forces, which means a high amount of heat, which standard room temperature does not give. And then intermolecular forces is also another idea that we have to keep in mind. And the stronger that these attractions are, the less likely a compound can exist as a gas at room temperature, because the stronger the attractions are, the more energy it takes to overcome them, and room temperature does not provide that kind of energy. I listed a few examples down here of each of elements and compounds, and these are only a few examples. There's a lot more that can be found in your textbook, but there's no real concrete way to find out if they exist as gases at room temperature.